32° north, automatically, let's say somewhere around here, 32° north. 47° west, 47° west will be like this. Turn towards the side, that's 47° west. Then we have 50, this is your north pole, this is your south pole, this is your east, this is your west. So we have 59° south. 59° south will be somewhere around here. 59° south. Then 47°. So the 2 points, we have the first point here, which is your Q, then the second point here, which is your P. So automatically, we locate them to the center. So when we locate them to the center and bring this out, it will look like this. With the diagram we're having will look like this, such that this place will be your Q and this will be your P. Remember that along the parallel of latitude, we know what an alternate angle is. So alternate angle are equal. So automatically this place should be 32. This place too should be 59. So since they are in opposite direction, we are meant to add them. So this is your theta. And your theta here, this is your center O. So your theta here, which is angle POQ, which is your theta, will definitely be, since they are in opposite direction, so automatically it will be 32 plus 59. And that will give us 191 degrees. So our theta is 91 degrees. So the distance is along the longitude. So automatically it will be along, the distance will be along the great circle. So automatically that will be distance. Since it's along the longitude, it will be theta over 360 times 2 pi capital R. That is along the great circle. So here, what is our theta? 91 over 360 times 2 times 22 over 7, provided that is what is given. Then this one is always your constant 6,400. So we use our mathematical set, our electronic device to find out that answer. That's 91 times 2 times 22 times 6,400 divided by 360 divided by 7. So that will give us 10,168.9. Don't let me approximate, just say 89 kilometers. Because I will still make use of this value. The question never asked me to calculate distance. The question asked me to calculate the speed. And since I know that speed is equal to distance over time, so automatically, since I have my distance is 10,168.89 kilometers, and the time that is given to me in the question is 14 hours. So automatically I can put 14 here in hours. So definitely I will have divided by 14. What I have divided by 14, then that will give me 726.35 kilometer per hour. Remember, the question asks us to calculate a speed correct to the nearest kilometer. So the nearest kilometer to this will definitely be 730 kilometer per hour. That is to two significant figure. So we have 730 kilometer per hour, and that is the speed. Distance along small circle. So distance along small circle is the same as distance along the parallel of latitude. So if you are asked to calculate the distance along small circles, let's say we have a shape like this. We have our Greenwich meridian, and we have our equator. So the distance along the parallel of latitude. So this is our R. So the distance along small circles is what we are to determine. So if you are asked to determine the distance along small circles, this is R. The formula: distance along small circle is also the same as distance along the parallel of latitude, and that is given as theta over 360 times 2 pi small r, where small r is r cos alpha. Take note of that. So this distance along small circle is also the same thing as distance along the parallel of latitude, and distance along great circle is theta over 360 times 2 pi capital R. But this time around, we have theta over 360 times 2 pi small r, where the value of this R is R cos lat, which is also known as R cos alpha. So let's see some examples to justify that. Example in figure 1.1a is a question. 2 points are this and this. So the first thing we have to do is to draw the diagram. So we draw the diagram. 2 points, P and Q. So our P is 32 degree north. So let's draw our Greenwich meridian, which is known as prime meridian. Let's draw it, and let's draw our equator. Let's see, this is our equator. 32 degree, this is our north pole, this is our south pole. So automatically we have 32 degree north. So let's say somewhere here, 32 degree north. Then we have 47 degree west. So we have our west. It is 47 degree west because it's our west direction, this is our east direction. So this one is 47 degree west. That is our point P. This point is our P. Then we also have another one, 32, it's still on the same point. Then 32 degree north, 28 degree east. 30 degree we face this side. So let's say this is 28 degree east direction. So we are talking about the distance. This is distance along the parallel of latitude. That's what we are talking about. Let's say there is a point here, there is a point here. So the distance along the parallel of latitude, because this is the parallel of latitude. So the distance along the parallel of latitude. So this is the point Q. So we are talking about the distance. We are talking about that distance. So the question asks us to. The question asks us, so this is diagram for the information. Find the radius of the parallel of latitude. We have to find the radius of the parallel of latitude through P. Through P, the radius of the parallel of latitude. The radius will be R equals to R cos alpha. That's the formula for the radius along the parallel of latitude. Then here we have, what is our latitude here? 32 degree north. So automatically we have R to be, this R is a constant, so it's 6,400 kilometers times cos lat. What is our latitude? We know our latitude is usually north and south direction, and here we have what? North direction. So our latitude here is 32 degrees. So we resolve this as cos 32, we multiply by 6,400, cos 32. Cos 32, we have this multiplied by 6,400 then we have 5,427.5. Our answer here, our R here is 5,427.5 kilometers. That's the value of our R. And that's our question. The answer to question 1A1. Then the A2, the distance between P and Q along the parallel of latitude. So the question A2 is asking us for the distance between P and Q along the parallel of latitude, along the parallel of latitude. So here what we are meant to use is theta over 360 times 2 pi small r, where small r is equal to r cos alpha. So I can rewrite this formula as theta over 360 times 2 pi r cos alpha. Since our small r is that value. So here, theta, what's our theta? Our theta is still, what did we get as our theta? Where is it? Our theta is, okay, theta has not been calculated before. So our theta, we have opposite direction. So automatically our theta will definitely be, our theta here will be 47 plus 28, since they are of opposite direction, or they are in opposite direction, so we are meant to add them. So we have 575 degrees, that's our theta.